to the Informs webinar. Today we're presenting our 2021 Steinhardt Prize winner, Dr. Edward Pohl. I want to welcome everyone for joining us. Thank you, Dr. Pohl. I wanted to remind everyone that this is being recorded. Please do make sure you're on mute to allow for the best audio performance. And we're going to also ask that if you have questions, please do feel free to either raise your hand or you can type in a message in the chat, and we'll be watchful for those questions so we can prompt Dr. Pohl for a response, or also feel free to wait until the end of the talk as well. So with that, I wanted to first mention to do a little quick in-house things. So again, want to thank you all for joining. As you know, this is the Informs Military and Security webinar series. We do want to make sure you guys check us out on the web, on YouTube. We have Twitter, we have Facebook, and LinkedIn as well. Make sure that you follow us there. I wanted to give a brief introduction. You already heard from our Vice President, Mr. Sean Doheny, who was gracious enough to open up this webinar. So thank you, Sean, for that. Just a little bit about, for those who are new joining us, thank you, welcome. Just wanted to remind you that military and security is here to foster development and dissemination and implementation of knowledge across military and security operations. We do have regular forums as well as webinars and other activities coming up soon, so be on lookout for that. These are just some of the great benefits of joining us. Take a moment to read at your leisure. And then with that, I wanted to just go ahead and get right into things with acknowledging our sponsor, CNA Analysis and Solutions, for the J. Steinhardt Prize. As a reminder, this is given for a work of life's work of work and contributions in the area of military operations research, and the award that goes along with that. So this is a combination of a lot of these things. And we also have Mr. Tim Cow here representing CNA. So we want to acknowledge him and thank you, Tim. And with that, I'd like to turn it over to Dr. Pohl, our 2021 Steinhardt Prize winner. And again, thank you again. I wanted to give you a chance to remind you of those things, and I'm going to stop sharing and let Dr. Pohl.
All right. Can you see my screen? All right. Well, thank you very much. It's a distinct honor to be here today. I'm humbled by receiving this award, and I wanted to thank the Informs Military and Security Society for this recognition. Today, what I'm going to do is I'm going to talk about what I call my 38-year adventure in the military and security domain. I'm going to take a walk through my career and talk a little bit about some of the things I learned, the projects I worked on, and some bits of advice for some of the more junior analysts out there. So again, I wanted to thank CNA for this award. I want to thank the prize committee, the 2021 award committee, and also to thank the College of Engineering, the University of Arkansas, for supporting me for the last 18 years in my endeavors in the area of operations research. So I'm humbled because of the list of names that have won this award in the past, and I'm especially humbled to be put in a group with folks that I've considered mentors and colleagues, and in particular, Greg Parnell, Marlon Thomas, and Dick Decro. Greg and I have weaved many paths I was a student at Affett when Greg was the department head there. And then Greg and I were on the faculty at West Point. Now Greg works in our department here at the University of Arkansas. That'll be one of the themes we talk about, the relationships you build and how they come back. Marlon was a mentor to me when I first became a PhD student and throughout my military and academic career. So I really appreciate his input into my career and my approach, especially in the research area and the reliability area. And of course, Dick was a colleague of mine when I was on the faculty at Affett. And Dick was also a battle buddy of mine when we deployed to Afghanistan in 2003. So where did my journey start? Well, I grew up just outside of Boston in a small town called Randolph. I grew up in a family. I have 5 siblings. We're all first generation college. We have 2 PhDs, 2 masters, and 2 folks who have bachelors in our family. So we really were able to take advantage of the opportunities in front of us. And that's the great thing about our country and the opportunities here in the United States. I was fortunate enough to attend Boston University, and I got a bachelor's degree in electrical engineering. And I'm still a lifelong Boston enthusiast, especially when it comes to baseball and hockey and football. So a high-level overview of my career. I spent a little over 20 years in the Air Force, and I'll go through that in detail. And then I've been here at the University of Arkansas for 18 years. Started as an associate, promoted to full. Worked as the director of our operations management program for about 7 years, and I've been the department head for the last, I'm in the middle of my 8th year right now. I've also had the opportunity to teach at a variety of other schools, Affett, West Point, and then a few schools while I was assigned to various parts of the country as an adjunct. I couldn't have done anything or any of this without the support of my family. So I wanted to take the time to thank my wife, Tish, who is, I believe, on the webinar as well, and our 3 wonderful children. They were extremely supportive throughout my career, and it's been a journey together for all of us in terms of the places and the things we've done. So I just wanted to say thank you to them. As far as my education goes, I was fortunate enough to have the Air Force pay for my education after my bachelor's degree. So I attended Affett, got a degree in systems engineering, and then I was selected for Affett Civilian Institution with the opportunity to come back and serve on the faculty at Affett. I was selected to come back and serve in the systems engineering program, which was in the aeronautic and astronautics department at the time. I got my PhD at the University of Arizona, and I also focused and specialized in the reliability area. So if you were to, it's in our department, we'll have a 1-slide visual for all of our faculty members. This is mine, and you'll see my research areas have been primarily in the stochastic modeling, risk and reliability. I've done some engineering optimization work, and recently over the last 6-7 years, working with Greg Parnell, we've done a lot of work in the systems engineering area. My application areas have been in homeland security, military operations research. I've had some experience in the healthcare segment, both while I was in the service and as well as here at the University of Arkansas, and then some supply chain risk work as well. Kind of a high-level look of some of the research products. You know, I've been fortunate enough to have my work accepted in a variety of journals. You'll see many of them are some of our operations research journals, EJOR, military OR, and OR decision analysis, as well as a variety of reliability and risk journals where a lot of my work has been published as well. I've been fortunate enough to have been invited to write chapters for a variety of books, including Dr. Parnell's trade-off analytics book, decision making book as well, and then a variety of other books on healthcare and logistics. Throughout my career, I've been active in terms of giving tutorials professionally, at a variety of conferences, primarily in the reliability area. And there's just a list of a few of the types of tutorials that I've given over the years. These are actually some of the more enjoyable things where we're able to get out there and interact with people who are trying to learn new tools and techniques to take back to the workplace. So I really do enjoy giving tutorials, and I've given them primarily in the reliability area on a variety of topics. Part of being a professional analyst and being a academic especially is to provide service to your profession. And I've provided service in a variety of areas to the Institute of Industrial and Systems Engineers in a variety of areas, primarily on the reliability side, but also on the engineering management side, the American Society for Engineering Management. I've been extremely active at Informs, having served as the MAS president way back in 2007, 2008. I was the MAS board of directors for a while during that period previous to that. I'm still active working with the Informs Analytics Conference. I had been on the Informs meeting committee up till a couple of years ago. I'm currently recently appointed the editor for the Journal of Military Operations Research. Again, I'm really excited to take on that new role. And again, to follow in the footsteps of some great previous editors, in particular, Greg Parnell, Dick Deckrow, and Ray Hill, all of who have been instrumental and played a role in my career. I'm about to give up, hopefully in the next month or two. They're still searching for my replacement. My role is the co-editor for the Journal of Engineering Management. And then I have a variety of associate editor roles in a variety of engineering management and risk and reliability journals. So what I'm going to do is I'm going to take a look at what I call the 5 Ps throughout my career: people, places, problems, processes. And then the last one is talk a little bit about presentation in terms of opportunities and what I can learn or have learned from those elements. So we'll start off with my first job in the Air Force. I came to Wright Pat one summer with about 350 or so second lieutenants. We were all there, brand new, most of us engineers. And I was assigned to the engineering directorate, ENS at the time, and I was assigned to the group that dealt with simulation and maintenance trainers at the home office. And while I was there, I had a great mentor, Dick Odell, who took me under his wing, gave me a few special projects to work on, really engaged me, challenged me. And after about 6 to 9 months, Dick helped place me in a rather unique position for a lieutenant. I ended up working, he took me down and placed me in the B2 program office, which at the time was a black program, which also at the time didn't have but maybe 1 or 2 other lieutenants in the entire program office. It was usually primarily made up of senior military folks. So it was an exciting opportunity. There I got to work with Major Paul Tofty and Mike Nichols. I worked primarily in the area of developing the B2 weapon system trainer, which was a unique opportunity and had some unique challenges. We were trying to build that trainer so that the trainer could be delivered when the first aircraft was delivered. So we were trying to design and develop the software for the flight simulator as the software is being designed and developed for the aircraft. So it was a unique opportunity to learn about how you integrate teams from one contractor with another to make sure that you're modeling correct and current configurations as they're being put out and developed. We also had some unique challenges that I'll talk about in a minute. I spent most of my time on the road. That was kind of unique, and I have to thank Tish for putting up with. We had a lot of meet on weekends in different places of the country, as we were both in the Air Force at the time, and she traveled a fair amount as well. So I traveled a lot primarily to Pico Rivera and Binghamton, New York, the Northrop Grumman and Singer Link. And spent a lot of time in the contractors' facilities, got to know a lot of the contractors, got to understand and see how they worked in the processes they used to develop the actual aircraft as well as the training system. So some of the problems that we dealt with were concurrent delivery, and then we were doing some firsts. We were delivering a trainer. We were going to use, we wanted to use object-oriented design, software design on the trainer. So we were one of the first groups to use Ada back then, which was the language of choice for object-oriented design. And so we were faced with all kinds of challenges. Because we had real-time requirements, we were pushing the state of the art for the compilers that we needed to run our software. So we spent a lot of time with the companies that were making compilers to make sure that those compilers could operate and run at the speeds necessary to make the flight simulator operate as it needed to give the pilots the correct cues as they were flying the aircraft. It was in this job that I learned a whole lot about systems engineering and the importance of systems engineering, the importance of writing good requirements. Learned a lot about software development, design, and test, and an extensive amount about project management. It was my first exposure to project management. As a student, as an undergrad, I never had a course. So I was kind of learning on the job about the importance of managing schedules, managing cost, and making sure that the product and performing as expected. This is my first opportunity to engage with senior military leaders. Regularly got to brief the senior leadership team in the program office. And I also got to work with fairly senior folks at the contractors, VPs and senior VPs at many of our meetings and weekly stand-ups. So it was an opportunity for me to see things from a different perspective than I may have in a regular SPO. After 3 years in the B2 SPO, I had the opportunity to go to AFIT, and as did my wife Tish. So we both went off to AFIT, and we both went off to the Master of Science program in Systems Engineering. I was selected for that program, and at the time they would choose what your concentration area was. Mine was supposed to be operations research and reliability, but I also had interest in other things. So I was a glutton for punishment, and I added a couple of extra concentrations to the curriculum, primarily because I didn't have to take some of the core courses because I had been working on my master's part-time at the University of Dayton. So I also focused in stochastic estimation and control for flight controls, a lot of work in common filter design. And then one of the areas that really excited me was decision analysis. Some of the people there, Dave Robinson was my mentor from the systems engineering department, my thesis advisor. Ken Bauer, who just recently retired from AFIT. I had him for several classes and really enjoyed him. He helped us out on our thesis. And Joe Topman. Joe was a professor in the math department, but he taught the decision analysis sequence, and he exposed me to decision analysis. I took 3 classes with Joe on decision analysis there. So he was kind of my trainer on the use of decision analysis. And then, of course, Ray Hill and I were students together. Ray was a year ahead of me, so we had a couple classes together, and that's where I first met Ray. And Ray and I developed a lifelong friendship from AFIT. And then one of my colleagues there, Jeff Jacobs, and I worked very closely together on our thesis. And what was unique about the systems engineering program is you had to learn how to do a thesis in a group of 5 or 6, depending on how many students were there that year. So it was all about doing system design in a team, which was good practice for what you might go out into the SPO world. So there we focused on doing some work related to designing an individual lift vehicle. Some of the processes that I learned, that's where I was formally trained in systems engineering. Learned a lot about team dynamics and trying to spend a lot of time with a group of 5 doing a thesis. learned my basic OR tools and techniques from the OR department there. And then I was there to learn reliability engineering as well. And I was also part of the R&M 2000 initiative, where they had selected a certain percentage of all students going through AFIT to go through an extra semester that focused on reliability engineering. So I had the opportunity to do that. And so I left AFIT with a very solid footing on reliability engineering. While at AFIT, I had my first opportunity to give my very first paper. It was at the National Aerospace Conference. And it was based on our thesis work, where we gave a paper on how do we create quality in system design. And we talked about robust design techniques using experimental design and trading off design characteristics and performance characteristics robustly. So that was my very first opportunity and engagement with writing a paper and giving a presentation at a national conference. So I have Dave and Dave Robinson to really thank for pushing me to do that. And Dave was the one who actually recommended to the leadership at AFIT that I be considered to come back from the faculty. My next job was a really enjoyable job because we went through that reliability engineering quarter. We had to go to a job that was coded, that needed reliability engineers. And so there was Tish and I both got to go work at the Air Force Operational Test and Evaluation Center. At the time, it was called LG4. It was the logistics group there. We focused on designing and developing tests and test plans, analyzing data sets, and making recommendations on whether or not the systems are meeting their reliability and maintainability requirements. While I was there, I had the opportunity to work under some very, very good people: Burt McKenzie, Jeff Olinger, Dale Kennedy, and then one of my colleagues there was Jim Wisnowski, who Jim and I have worked together several times since Afotech. Jeff Olinger was one of the branch directors there. He's now I think he's the chief scientist at Afotech. And Jeff and I have encountered each other throughout my career as well. He actually sent us a student to get her PhD here at the University of Arkansas. So again, an importance of establishing relationship, building relationship with people, and how that can impact you later. It was a great job. I worked on a variety. I was in the missile systems branch, and Dale Kennedy was my branch chief. I worked on a variety of missile systems, got to travel to the glorious places like Edwards, Eglin, and Offutt. I worked on the AGM-130 air-to-ground missile, AGM-129, which was the AMRAAM, and the AGM-129, and the AGM-131, so the Advanced Cruise Missile, and the SRAM-2, which eventually got canceled. For those programs, I actually used some of the tools that I studied at AFIT. We modeled using simulation tools the flow of missiles in the maintenance structure, and computed things like system availability, modeled resources, and what the impact of what the required resources were in terms of maintenance technicians. We also did test design and analysis of actual test data from flight test. And this was my first exposure to using things like design of experiments, reliability growth, and modeling and simulation. I had a unique opportunity at that time where we were doing a fair amount of work on reliability growth, and reliability had become a hot issue at OSD, DOT&E. And so I had the opportunity to go up to OSD with Burt McKenzie and talk to the senior science advisor about how we use reliability growth and how it's important as part of the design process. So that was a unique opportunity. And it's interesting because I've continued to do research in my career around the topic of reliability growth, and it's still a hot topic in the Air Force. After that, I had the opportunity to go back to school. I went to the University of Arizona, where I met a wonderful group of faculty members. My advisor was Dwayne Dietrich in the reliability area. Jeff Goldberg, John Ramberg, Rajit Sen, Julie Heigl, all of them were great faculty members. I still have professional relationships with several of those folks. And I met a group of wonderful students. I met Mike McGinnis, who at the time was an Army Lieutenant Colonel getting his PhD. Bridget and Mike were Army captains getting their master's degree. And then a couple of other colleagues, Panelise Vasilio, who I as a student who went on to found his own company called Reliasoft, and he and I had a relationship for the next 20 years after I graduated. And then Feng-Bing Sung was a colleague of mine and a fellow student. There I was in Tucson, Arizona. It was a great place to go to graduate school. The types of problems I worked on in my program were focused in reliability, and in particular in the environmental stress screening, which was the process of determining how do we determine what the right amount of test time is, the right level of stress to kind of weed out defects for at the types of systems I was looking at were electronic systems, both at the board and subsystem level. So we subject those items to multiple stresses and determine part of the challenge is to optimally determine what the right stress levels and the right amount of time at each of those stresses, such that we minimize the cost, and we create a cost model that trades off the cost of products against the cost of testing and the cost of using up some of the useful life of the product as it goes through environmental stress screening. So again, re-emphasize the systems engineering training that I had already seen, was exposed to probabilistic design quality, and re-emphasize some of the OR tools that I had seen as a master's student. This is where I wrote my first journal paper. And I remember when Dr. Dietrich, this was in the day when you had to mail a paper and you had to wait for the reviews to come back. And I remember he called me into his office and he got a letter, and he hadn't opened it yet. He said, "Well, I think this is your reviews on your paper, and it doesn't look good." I said, "How do you know?" He said, it's a pretty small envelope and it doesn't have a whole lot there." So he opened it up, and he said, "I don't believe it." He said, "Your paper was accepted as is." He said, "I never had that happen in my career." And it hasn't happened to me since. So it was one of those situations where you spend enough time on something early, and you're fortunate to have it accepted. That was the only time he said in his career that he had a paper accepted without revision. So that was a unique circumstance there. But I'll tell you, it never happened again. Every other paper I ever tried to publish had at least one, sometimes two revisions that went with it. And this was the first time I got exposed to a conference that I spent and still spend a significant amount of time with, which is called RAMS, Reliability, Availability, Maintainability Symposium, which is a conference that's made up of 10 professional societies. And this is where I built a large part of my network, research network in the reliability area, with professionals from IEEE, IIE, AIAA, the Society of Reliability Engineers, ASQ. So it's a large conference focused on reliability. And I made my first presentation there while I was a graduate student. And I later became an active participant in the conference, and eventually went on to chair the conference one year. So that was a big part of my professional network. After I graduated, I got to go back to AFIT, where I was an assistant professor of aerospace and astronautics, where I was teaching systems engineering and reliability in the Aeroastro department. I was also teaching some OR techniques, primarily nonlinear program, to the some of the OR students and the Aeroastro students. And I did get the opportunity to teach some decision analysis in the OR department, primarily because Paulo Claire at the time had asked my department head in the Aeroastro department if he would be willing to let me teach DA. So that was a unique opportunity, and I really enjoyed that opportunity. Some of the people I worked with and collaborated with while I was there: Dick Decro, Paulo Clare, Ray Hill, Paul Murdoch. Some of the great students that I encountered while I was there. That's one of the things about AFIT. You have outstanding, dedicated students. Darren Durkee, Dave Renicky, who got his PhD while I was there. Pete Vandenbosch, Mike Payne, Rob Nair, Todd Shriver, all have gone on to do great things in the OR community. The types of problems, research problems I worked on while I was there, primarily in the area of reliability and maintenance. I did some work with the AMRAAM SPO. I did some work with the, at the time, we were just getting into UAVs, so I did some work with the Global Hawk and Dark Star folks. I was on some red teams to look at those programs as they were going through review, so that was a unique experience. In my research area, some of the research areas that I focused on were things like selective maintenance, preventative maintenance, and design optimization. While I was at AFIT, that's where I first published my first paper in the Journal of Military OR. It was actually a paper with a student who I was working with from the environmental engineering group, and it was on using decision analysis to support decisions related to the Pacific pocket mouse. It was an endangered species out at Camp Pendleton, and so we developed a decision analysis framework to help make decisions about how to design and allocate your training area based on the habitats associated with where the Pacific pocket mouse were breeding. And this was my first opportunity to engage with informs. So I was at AFIT, started to present regulated informs in the mass group. After AFIT, I had a really unique job, an opportunity. I got to go to OSD, PA&E, and the Cost Analysis Improvement Group, and worked as a OR analyst. There was usually one member from each service, and then the rest of the folks were folks primarily with PhDs, working and supporting the acquisition programs. So the people I got to work with were Dr. Dave McNichol, who was the head of the KEG, Dr. Rick Burke, who was my branch chief, and then Steve Miller, who was a co-worker who gave me immense support, helped me whenever I encountered problems, and provided me a lot of insight, especially on the technical side of some of the systems I was working on and studying. I worked on a variety of programs, Air Force, Navy, and Army. The types of problems I was doing there, one of the roles were for us to create the ICE, the independent cost estimate, for all ACAT-1 acquisition programs that would go into Congress. So we would go out and do the independent cost schedule and performance analysis on these programs as they were coming up for their milestone. So I was learning how to build cost models, schedule models, risk models, do an analysis on whether or not we thought the programs would meet their performance requirements based on their development testing or early OT&E testing. The types of programs I worked on at the time were national missile defense, some satellite programs, in particular the advanced EHF satellite. And then I also got to work on some other Department of Defense programs that as part of the PPBE program planning and budgeting exercise each year, they do some short exercises about putting money into specific programs. So I had the opportunity to work on DLA related programs, care, health. So it exposed me initially to some of the issues with healthcare and healthcare delivery. And we did some modeling. Probably the most interesting thing I learned in one of these programs was we were looking at logistics problems in terms of having spare parts for some of the fighter jets. And one of the things that we found was that a lot of the warehouses had moved to kind of best business practices. And one of the best business practices or measured performance was supply availability. When we started to look at the data, we found out that the warehouses were incentivized to stock low-cost, high-moving items to keep their availability number high. And there was really no incentive to stock the slow-moving, high-cost items. So that's why, in some instances, we would run out of parts related to aircraft because they tended to be slower moving and high cost. So one of the things we helped do was infuse I think it was $450 million into the supply chain, and in the aircraft area in particular for the fighters, so that we could get their supply levels back up to where they need to be. And then we talked about creating supply availability or rates by segment rather than just an overall measure. Some of the tools, again, we used risk analysis, statistical analysis, parametric cost estimating. I had some great opportunities to brief a lot of the OSD leadership, sit in on briefings to the Secretary of Defense, spent a lot of time over at the Office of Management Budget, some of the leadership over there, and got to talk quite frequently to Senate and House staffers who were interested in some of the acquisition programs that we were working on. I got to present regularly at the annual DoD cost analysis symposium. My last assignment was at the United States Military Academy. And again, you'll see some familiar faces and names. So Mike McGinnis had gone back to the Academy and was the department head. And after I had finished my assignment, I was leaning towards or possibly heading towards the Air Force Office of Scientific Research for my next assignment. And Colonel McGinnis called me and said, I've got a Lieutenant Colonel's Air Force position. Is it something you're interested in? And Tish and I talked about it. We thought it would be a great opportunity to go to the Academy. And so I said yes. And fortunately, it got worked out and we were able to go there, and I was able to be on the faculty. Got to re-engage with Mike and Bridget, made some additional friends, Dan Carthy, other people that were there, Pat Driscoll, Bob Foote, Bill Climack, who I first met because he was a student at AFIT, and now he was the director at the time of the systems engineering program at West Point. And then Greg Parnell was a senior faculty member there. So that's where I got to know Greg at a collegial level as opposed to a student level. Spent most of my time at West Point, but while I was there, there was a call for some support to the Combined Joint Task Force in Afghanistan back in 2003. So Mike Quinn and myself, and then Dick Deckgrove from AFIT, went over and supported the Combined Joint Task Force in terms of helping them create some operational assessment decision support tools. We used a lot of decision analysis tools and frameworks to help build out that process. One of the things we learned is that we spent a lot of time doing stakeholder analysis in the theater, trying to understand what were the right things that we should use to measure and assess progress in the theater. We'd come back, worked with the folks back at West Point, created the tool, came back, briefed the local general on the tool. He really liked it. During the time we built the tool, from when we first started, we had a new general show up down at the theater commander down at the embassy. And when we went to brief him, he didn't want to have anything to do with a tool that would measure progress. So it was one of those cases where we spent a lot of time on a problem. We thought we were doing the right thing, and then you get a new leader and things change. This was the first time that I got the opportunity to go out and travel internationally, presented at the South Korean Defense OR Symposium, War Symposium, and the Corps Inform Symposium. Last but not least is the University of Arkansas. I've been a professor of engineering here. Had some great folks, John English, Richard Cassidy, who I met when I was a brand new PhD student, and John was a faculty member here in the reliability engineering here. Richard was a student at Virginia Tech. When I retired, they recruited me heavily to come to Arkansas. So I thank them for that. John White, who was the chancellor, and came back to the faculty. I got to know John at a very personal level. He was a great great leader and great mentor. I really appreciate the opportunity to do that. Kim Needy and Greg Parnell. Kim came to be department head after John left. Greg came after he retired from West Point, as he likes to say, failed retirement for the third time. And so he came to as a visiting professor, and we loved him so much, we brought him on full time as a professor of practice, and he's been here ever since, doing great things for us and our students. And some of my colleagues, Chase Rainwater and Hightower Liao. We've had some great students here: Eric Specking, Cesar, Tom Talafus, and Nick Shawcross. Outstanding PhD students who we've done great things with, and who themselves will go on to do great things. One of the great things about being at an academic institution like the University of Arkansas, you get to go to great places. So I began to do a lot of international presentations internationally in the reliability in our area. So I'd go regularly to Informs International and to Israel. A lot of travel to Europe: Helsinki, London, Paris, Frankfurt, Manchester, Barcelona, primarily doing presentations and presenting research related to risk and reliability. The types of problems I've been working on, I had the pleasure to be part of the Science of Test team. That was something that Ray Hill helped facilitate. That's a project that consists of several universities doing focused research related to tools and techniques that would be of benefit to the DOT&E community. The types of work I've done is continued selective maintenance, testing, reliability growth, design of experiments. And then Greg and I have done a fair amount of work recently for ERDIC, which is the Engineering Research Development Center of the Army, out of the Army Corps of Engineers, things related to border security, telecommunications, and UAV design. Here we've spent some time developing some new systems engineering related techniques, focusing on integrated modeling techniques, set-based design, uncertainty analysis, and trying to quantify the value of information. So what have I learned? I've learned that good people are the key to success. Collaboration has enormous benefits. Great colleagues make work exciting and fun. Places, problems in research can take you around the world. Enjoy the journey. The problems, all problems are interesting, some more than others. All problems are unique. Take the time to really understand them. Look for the root causes in the problems and make sure you're solving the right problem, not the problem you want to solve. Processes. We need to be flexible in our approach to solving problems. Understand the process and be willing to learn and use new tools and techniques as necessary. And finally, presentation. Tell a good story. Keep your presentations as simple as possible. When I think back to our DLA project, Dr. McNichol had told us that for several years they've been trying to infuse money into DLA to increase the spares provisioning, primarily in the engine area for the fighter jets. And they were having a hard time convincing the very senior level of OSD to do that. And one of the things, very simple idea, when we looked at the size of the number of aircraft that were down because of parts that should have been in the inventory system, we had almost the equivalent of the Canadian Air Force sitting on runways waiting for parts. Put up a slide like that, and he was able to get that funded pretty quickly. So, you know, that visual perspective and related to something meaningful, but keep it simple, really can have an impact on decision makers. And with that, I think I'm going to stop here and open it up to questions. Again, I wanted to thank the committee and thank the society for this recognition.
Excellent. Thank you so much, Dr. Pohl. That is a wonderful presentation, and I really appreciate your insights, sharing those insights with the community today. And as a reminder for our audience, the Steinhardt Prize is awarded for contributions to the military ops research community, spanning the award winner's life rather than for a specific contribution. And what Dr. Pohl has shared with us today definitely highlights why he was selected for this prestigious award. But to be clear, Dr. Pohl isn't retiring, and we are so fortunate that he remains so engaged. Congratulations on your selection as the editor for the Military Ops Research Journal, and we're just so thankful to see that continued engagement and that commitment to the military and national security operations research community, Dr. Pohl. We look forward to seeing and reading about many more great contributions ahead. I'd like to turn the floor over to the sponsor of the co-sponsor of this award. Excuse me. Our CNA is the sponsor for this prestigious award, and we are very fortunate to have Mr. Tim Gao with us with CNA. Tim is the Vice President and Director of CNA's Data Science Division, and again, we're very thankful to our CNA sponsor for this award. So over to you, Tim.
Thanks, Sean. Congratulations, Dr. Pohl. On behalf of CNA, we're proud to sponsor the Steinhardt Award. As you know, Dr. Steinhardt was the second leader of the Center for Naval Analysis organization that started operations research in DoD and the United States, right? So Bill Morris, of course, was the founder of the initial operations evaluation group that was known as the Anti-Submarine Warfare Operations Group, became OEG, and then he passed the reins over to Jay Steinhardt, who made his name during World War II as well, using search theory, helping sink 4 German freighters that were trying to transit from the Pacific to the Atlantic to resupply the German lines, and his search theory methodology in Brazil helped apply it. So your discussions about deploying and going around the world and helping out on the front lines, that resonates definitely with us here at CNA, and so we're certainly proud to be a sponsor of this award and hold up the values that we have here at CNA, which is to really put the scientists out front with the decision makers so that we can best help them with their problems. And so to keep it simple principle, I love it. I feel like the supply problems that you've identified still impact the Navy and Marine Corps today. So just because they've solved once before doesn't mean they've been solved across DoD or those industries. And so those lessons learned continue to be honored and applied every day. So congratulations again, and well done. And certainly a wide breadth of work, both in your time in uniform and certainly even more now having left the services for a longer period of time. So thanks, Sean, and congratulations.
Thank you, Tim. And congratulations again, Dr. Pohl. I know we have a few minutes where we can open up the floor for questions. And if you do have any questions, feel free to use the raise hand feature, and I'll make sure that you have the ability to come off mute and answer that, ask that question, or you can drop it in chat. Lots of folks attending, congratulating you, Ed. And I also see some of the names that you mentioned in your slides joining us today. So Kim Needy and Greg Parnell and many others, as well as family members joining today too. So, and it really does take the village, that collaboration, that support to do this important work as you demonstrated. So thank you again for that. We do have we'll be ending in about 5 minutes. There is another webinar that will be taking place, but we do have time for a couple questions if there are any. And not seeing anything in chat, I actually have, I'd be very interested in your thoughts, Ed, as how has operations research and reliability analysis, your specialty clearly, how have you seen that changing over the course of your career?
So it's changed significantly. As a matter of fact, I'm going to go down one more, move down one more slide. So, you know, from a reliability perspective, we're always looking for data. You know, never enough data, right? Never enough test time. But with the advent of sensors and the ability to model things beyond just failure, but modeling degradation of systems, the number of sensors, the low cost of sensors has really changed the analysis dynamic. You know, when we talk about analytics, which is the buzzword today and the hot area for people, everybody wants to be hiring analytics trained folks. This second area here, diagnostic analytics, the amount of information that's now available to be able to understand what's going on, you know, vibration, temperature, those sorts of things on products that are in the field, and the ability to relay that information real time enables us to do a whole lot more when it comes to things like predictive analytics and then prescriptive analytics. When we learn and predict when we expect something to fail, what are the processes we need to do? When's the right time to bring it in for maintenance? Those sort of things. And then the latest surge is in the area of AI and machine learning. And so given all this data that's now available, how can we tease out some things that aren't evident by some of the tools that we've traditionally used? And so we're seeing a whole surge of work being done in the reliability area and in the OR area, where we're beginning to take advantage of some of the more advanced tools and techniques related to AI and machine learning. I mean, some of those tools were built off of some of the predictive analytics tools and prescriptive analytics tools that we're all familiar with, but there are a whole set of new tools and techniques that enhance our capability to mine that data for information that helps us make better decisions.
Excellent. Yeah, very, very insightful. And thank you so much for that. We might have time for one more question. Again, lots of congratulations. Absolutely want to echo those as well. In the meantime, we probably have about 2 more minutes, and then so I am curious, and this is probably more than a long 2-minute question, but in the area of analyst education, you know, what topics were you taught that maybe they aren't being taught anymore, or you know, we should bring them back, or what are we doing well? I'm just curious as to your thoughts on how we're training our analysts today.
You know, I feel like I benefited from, I wasn't a pure OR person. I didn't go through the OR program by itself. I was a systems engineering person who took a sequence of courses in OR where I was exposed to the fundamental, you know, linear programming, nonlinear programming, and some stochastic processes. Modeling. And then, and so I felt like that system perspective is really critical, and it really helped me in my career. And I think that's something that would help our analysts, you know, to look at things from a systems perspective, because sometimes our analysts get infatuated with a particular tool or particular tool set and try and fit that tool or tool set to most problems that they see. I think seeing things from a system perspective enables you to look at things a little more openly, and with the ability to think about what really are the challenges and what are the best ways to maybe attack those types of problems. And the other thing is the importance of process, how important process is to the success of any system, controlling the process, defining the process, maintaining the process.
Great. And I know you and Dr. Parnell are doing some great work in that set-based design process domain. So we look forward to seeing more on that. Well, with that, Dr. Pohl, I'll go ahead and wrap us up. I do want to once again congratulate you on this outstanding achievement. We look forward to the many contributions still ahead. I want to thank CNA, Tim Gow, thank you for joining us and our sponsor and sponsoring this award. I also want to thank Alicia Bridges, who's on the line, and Dr. Fred Woodeman, who wasn't able to join us today, for helping to organize today's webinar. And I want to encourage everyone to continue to reach out to us. Let us know what topics you would like to hear about in the next webinar that we're lining up for you, and how we can help contribute to what you're doing in the community. So thank you for joining us today, and we look forward to seeing you again very soon. Thank you again.
Thank you.